This video is the normal distribution part 3. We had just finished talking about how to use your calculator to calculate the area under the normal curve, which represents two things. It represents the proportion of the population within the boundaries you've given, and it also represents the probability that an individual chosen from the population would be within those boundaries. And we would do this by doing the function in the calculator called normal CDF. We hit second vars. We would choose number 2. We need the lower boundary and the upper boundary, the mean and the standard deviation. For those without prompts, you have to enter those 4 numbers separated by commas in that order, and then hit enter, and you will find your area or the proportion or the probability, depending on what the question is asking for. It finds all 3 because all 3 are the same number. We also talked about how the number you get should be between 0 and 1. So we're going to go backwards, and we're going to find the area under the standard normal curve. Now, reminding you, the standard normal curve, the standard normal curve is a curve that has a mean of 0 and a standard deviation of 1. Now, I had quickly shown how to use a table to find this area. However, it's much quicker to use the calculator, so that's the way we're going to go. So to find the area to the left of z equals 0.47, so the first thing that I always do is I draw this curve out. And I label the mean, which happens to be 0 because it is a standard normal curve. Again, the standard deviation is 1. Now we want to find the area to the left of 0.47. So if 0 is in the middle, positive numbers are to the right, negative numbers are to the left. So I'm just going to approximate 0.47 to be about here. It doesn't have to be super accurate. We're just approximating where it is. We know it's somewhere to the right of 0. Now we want the area to the left. So what I do is I draw a vertical line to be the boundary at that z-score at 0.47. And we want the area to the left. So we're going to shade, I'm going to use the highlighter, we're going to shade the area to the left of that number so that we can see that this is what we're looking for. We're looking for that area to the left of z equals 0.47. And we have illustrated that with this curve. So if you will remember, to find area, we use normal, let me change that to a pen, normal CDF. And you need 4 numbers. You need a left boundary, I'll write this up here, a left boundary, a right boundary or an upper boundary, the mean, and the population standard deviation. The population standard deviation. So we need the lower boundary and the upper boundary, or the left boundary and the right boundary. So I can clearly see that the right boundary of the shaded region for the area I'm looking for is 0.47. What I can't see is what the left boundary is. The right boundary is 0.47. The right boundary, we don't know. So we think about it this way. This keeps going on forever to negative infinity. So technically, the left boundary is negative infinity. So what I want to do is I want to talk about infinity for a second. So let's go to a white screen. We have negative infinity. We have positive infinity. To my knowledge, there's not a button in the calculator that represents this. So what we can do is we write a number that is so far to the left for negative infinity that the answer that you would get if you use that as a left boundary would be the same answer, or approximately the same answer you would get if you had actually entered negative infinity. So what we do is we type in -1 E 99. What that means is scientific notation, it's -1 times 10 to the 99th power. And to go even further, that really means -1 with 99 zeros attached to it. That's a really far number to the left of 0. It's headed towards negative infinity, so that's why we can use that number to represent infinity. Now, how do you type that into the calculator? You would type -1, and then E is actually, you will see it as an EE written above a comma. It's a secondary function, but the EE will pop up as that capital E there. That's different than alpha E, so please don't hit alpha E. You will not get the right thing there. So second, and then type in comma. It doesn't want to do the comma. So that funny looking thing is a comma there. Sorry about that. And then you would type in 99. For positive infinity, it would be the same thing. Instead of -1e99, this would be for an upper boundary that went to positive infinity. You would type in 1e99. So with the calculator, you would hit +1 second, comma, 99. Now, that is not the only way that you can do it. Sometimes people don't like to worry about hitting the second and the comma and all of that. So sometimes people just put a very large number in the left direction, so towards negative infinity, and they just type negative and a lot of 9s. If you hear the noise in the background, that's my cat going a little spastic. Sorry about that. The cat has found a plastic bag. Actually, I'm going to pause the video and go get the bag off of my cat's neck. Okay, unpausing the video. The cat is fine. Okay, back to over here. We were talking about how to type positive infinity into the calculator. 1e99. We would get there by typing in 1 second, comma, 99. Or you can just enter a really large number. I usually just enter a lot of 9s. But that's how we handle infinity and negative infinity in the calculator. Okay. All right, back to our other screen. So we want to go from negative infinity to 0.47 to find the area to the left of 0.47. So negative infinity, I'm going to type in -1e99, comma. Then the right boundary, or the upper boundary, is 0.47, comma. Then the mean is 0, and we follow that with a comma. Standard deviation is 1. This is how we would show our work. We would write out normal CDF. You would write the left boundary, right boundary, mean, and standard deviation in parentheses, separated by commas. That is how you show the work for something like this. So let me pull the calculator up. Oops. And here we go. So we're going to type in, oops, I have 2 calculators. We're going to type in this normal CDF. So just to remind you, to get there, we go to second vars. You will see normal PDF is first, followed by normal CDF. We want normal CDF, number 2. So you can either scroll down to 2 or just hit the number 2, which I find quicker. Now, your screen at this point will be different depending on which kind of calculator you have. If you have the prompts, it says lower. The default that is typed in is already negative infinity. You can see that. But let me clear this out so I can show you how to type it in. Now, you can either type in -1, and then E is above the secondary function above the comma. So second negative 99. You can enter it like that. Or you can enter negative 9999999. So I don't have a specific number of 9s. I would say 6 or more should do it. But there you have it. You can type that in as well. I'm going to go back and put the infinity in. And then for the upper boundary, we want 0.47. And then for the mean, it's 0. For the standard deviation, it's 1 because it's a standard normal curve. And then we go to paste. Now, if you didn't have the prompts, you would have entered the negative 1e99, comma, 0.47, comma, 0, comma, 1, close the parentheses after the normal CDF. So we're going to hit enter, and we see that the area underneath the normal curve to the left of z equals 0.47 is 0.6808 if we round to 4 decimal places, which is what we want to do for probabilities, areas, and proportions. 0.6808. All right, so let's do the next one. We're going to find the area to the right of negative 1.24. So here's 0 in the middle. Negative 1.24 somewhere to the left. So I'm going to say it's right here. Again, it doesn't have to be perfect. We want the area to the right. So I'm going to shade to the right. So we want to find that area there. So for this one, our left boundary is negative 0.124 and our right boundary, so this is the boundaries that hold the area that we've shaded, the area to the right of negative 1.24. So the area to the right is positive infinity, which we will enter as 1e99. So in the calculator, we're going to do normal CDF. And then we're going to put in our left boundary, which is negative 1.24, our right boundary, which is 1e99, our mean, which is 0, standard deviation is 1. So second vars number 2, second vars number 2, not sure what I did there. Our left boundary is negative 1.24. Our right boundary is 1. Sorry about that. Our right boundary is 1e, second comma, 99. Our mean is 0, standard deviation 1, paste. And we get 0.8925 when we round to 2 decimals. 0.8925. All right, so now we're going to find the area between 0.86 and 1.15. So 0 is in the middle. 0.86 is positive, so I'm going to put it's right here, 0.86, and then I'm going to draw a boundary there, 0.86, and then we're just going to say 1.15 is here. Again, it's not perfect, but this is the area that we're looking for. What I like about this kind of problem is that you don't have to worry about infinity being your boundary. So this would be normal CDF. Left boundary is 0.86. Right boundary is 1.15, 0, 1. So calculator second vars, number 2, we want 0.86 as our left boundary, and our right boundary is 1.15. Mean and standard deviation stay the same, 0 and 1, and we get 0.0698. Okay, so we got 0.0698 for the area between 0.86 and 1.15. We're going to pick up with this last portion of example 3 and in part 4 of the normal distribution.